Hello, and welcome to today's podcast. The podcast will be a reading from the Science, A Closer Look series by Macmillan McGraw-Hill. Today we will be looking at minerals and how scientists use their properties to identify and classify them. The second half of the podcast will discuss and compare three types of rocks: igneous, sedimentary, and metamorphic. Why are rocks so different from each other? To answer that question, it helps to know about minerals. A mineral is a natural, non-living substance that makes up rock. In fact, minerals are the building blocks of rocks. Scientists have identified more than 3,000 kinds of minerals. How? They observe the mineral's properties. A property is a characteristic that describes something. One property is color. Talc, for example, is white. Topaz can be blue. Color alone, however, cannot identify minerals. Many minerals have the same color. Quartz, on the other hand, can come in many different colors. Another property is hardness. Hardness is a property that refers to the mineral's ability to scratch another mineral or be scratched by another mineral. Mohs scale shows the hardness of a few common minerals. Each mineral has a number from 1 to 10. 10 is the hardest kind. The harder a mineral is, the more it resists scratching. As the scale shows, diamond is the hardest mineral of all. Another property to determine what kind of mineral it is the luster. Luster refers to the way light bounces off the surface of a mineral. Some minerals have a metallic or shiny luster. Minerals that have no shine at all have a dull luster. Other lusters may be described as glassy or pearly. The last property we'll discuss is streak. When you scratch a mineral along a white tile, it leaves behind a powder. A streak is the color of that powder. The streak may be different from the color of a mineral surface. All these properties, whether it be the color, hardness, luster, or streak, help scientists identify what type of mineral they are working with. Now we are going to look at the three types of rocks: igneous, sedimentary, and metamorphic. Have you ever wondered how a rock forms? Its minerals offer us clues. Our first type of rock is the igneous rock. Below Earth's surface are areas of melted rock called magma. When magma cools and hardens, igneous rocks form. Igneous is a Latin word meaning fire. Igneous rocks form from melted rock, either from magma below Earth's crust or from lava above it. When a rock cools slowly, large mineral grains can form. The cool rock looks rough or coarse. Texture is a property that describes the appearance of the rock. It is related to the size of the mineral grains. If a rock cools quickly, there is no time for large grains to form. Let's look at some examples of igneous rocks. We are going to look at obsidian and basalt. Both obsidian and basalt cool quickly. Obsidian is smooth and glassy. It is cooled so quickly that the mineral grains did not have time to form. Basalt has small mineral grains because it cooled more slowly than obsidian. Granite, on the other hand, is different. It is cooled slowly underground. It had enough time to form large mineral grains. Our next type of rock is sedimentary rocks. Sedimentary rocks form from sediments, such as rock deposits, minerals, plants, shells, or other materials that are cemented or pressed together. Wind and water deposit most of the sediments. Over time, new sediments are deposited on top of the older layers. Sometimes, dissolved minerals will cement the sediments together. Other times, the weight of the top layers presses the sediment together. It can take millions of years for sediments to become a rock. The layers in sedimentary rock are stacked in order of their relative ages. Relative age is the age of one thing compared to another. The older the relative age of the rock layer, the lower it is found. Relative age also applies to any fossils in the rock layer. A fossil is a trace of something that was once alive. The last type of rock we're going to discuss today is metamorphic rocks. Temperatures below Earth's surface can be very high. Pressure there is high too. When rocks are under so much heat and pressure, their chemical properties can change. Rocks formed from other rocks by extreme heat and pressure are called metamorphic rocks. These rocks can form from igneous, sedimentary, or even other metamorphic rocks. The properties of metamorphic rocks depend on the amounts of heat and pressure. In some rocks, the minerals get rearranged and pressed into thin layers. These layers are called bands. Bands may be straight or wavy, and with enough heat and pressure, they can become colorful. Some metamorphic rocks form from sedimentary rocks. Marble, for example, forms from limestone. Unlike gneiss, marble does not have bands. Quartzite is another metamorphic rock that does not have bands. It forms from sandstone. You have learned how igneous, sedimentary, and metamorphic rocks form. Does it surprise you that they can all change from one type to another? The rock cycle shows how rocks change from one form to another. It shows how rocks are related to one another. As you can see on the next page, the rock cycle has many paths. It takes millions of years. Rock materials are moving through the rock cycle all the time. Weathering and erosion breaks rocks into sediments and carries them away. The sediments get deposited somewhere else. They slowly press together to form sedimentary rock. Any rock can melt and cool to form igneous rock. Under extreme heat and pressure, some rocks become metamorphic. In time, weathering and erosion break those rocks apart, and the cycle goes on and on. Rocks and minerals are resources, materials from Earth that have useful properties. You can see examples all around you. Granite is strong and long-lasting. These qualities make ideal for building schools and other structures. Pumice is found in some soaps and cleansers. Its rough texture helps to scrub off dirt. Limestone is often used to make glass. Shale is used to make bricks, china, and pottery. When shale is combined with limestone, it can be used to make cement. Scientists use the layers in sedimentary rocks to piece together Earth's history. Slate is waterproof. It's a good choice as tiles for roofs, billiard tables, and walkways. Marble is valued for its beauty and strength. We use it in flooring, hearths, monuments, and statues. It's easy to carve, and it resists fire. In conclusion, rocks and minerals are valuable. Scientists classify these resources by observing their properties. All rocks, whether they be igneous, sedimentary, or metamorphic, can be useful based on the properties they possess. Thank you for listening to this podcast.